Dr. Binu. In Artificial Intelligence and Machine Learning Fundamental Subject, the sixth topic in the fourth unit is support vector machine. The support vector machine is one of the popular classification algorithm which comes under the supervised learning. Support vector machine is used for information regression and classification. It is usually used for grouping issues. It can be compatible with filters. The filter will be added below the expression if we carry out specific looks between happy and sad or the possible expressions. SVM is a powerful algorithm for both classification and regression tasks. It finds the best hyperplane that separates classes in high dimensional space. SVM has applications in text categorization, image recognition, and gene expression analysis. It is a type of classification algorithm that classifies data based on its features. SVM will classify any new element into one of the two classes. Once you give it some input, the algorithm will segregate and classify the data and then create the output. When you give more data, that is, if unknown fruit variable is given, means it correctly classify the fruits as either apple or orange. The linear SVM classification problem with a 2D dataset. The goal of this problem is to classify the cricket players into batsmen or bowlers using run to wicket ratio. A player with more runs would be considered as batsman and a player with more wickets would be considered as a bowler. If you take a data set of cricket players with the runs and wickets in columns next to their names, you could create a two-dimensional plot showing a clear separation between bowlers and batsmen. We present a data set with a clear segregation between bowlers versus batsmen to help understand SVM. When we plot the data, we can see a clear separation between the class of batsman and bowler by means of this diagrammatical representation. Before separating anything using high level mathematics, let's look at an unknown value, which is new data being introduced into the data set without a pre-designated classification. The next step is to draw a decision boundary or a line separating the two classes to help classify the data points. We can actually draw several boundaries as shown above. We need to find the line of best fit that clearly separates those two groups. The correct line will help you to classify the new data point. You can find the best line by computing the maximum margin from equidistant support vectors. Support vectors in this context simply mean the 2 points, one from each class that are closest together but that maximize the distance between them or the margin. We can think the word vector refers to data points. While this may be the case in two-dimensional or three-dimensional spaces, once you get into higher dimensions with more features in your data set, you need to look at these vectors. The reason they are support vectors is that two vectors closest together maximize the distance between the two groups supporting the algorithm. There are some couple of points at the top that are pretty close to one another, and similarly at the bottom of the graph shown below are the points that you need to consider. The rest of the points are too far away. The bowler points to the right and the batsman points to the left. Mathematically, we can calculate the distance among all of these points and minimize the distance. Once you pick the support vectors, drawing a dividing line and then measure the distance from each support vector to the line. The best line will always have the greatest margin or distance between the support vectors. For instance, if you consider the yellow line as a decision boundary, the player with new data point is the bowler. As the margin don't appear to be maximum, you can come up with a better line. Use the support vectors, draw the decision boundary between those, and then calculate the margin. The unknown data point would be considered as a batsman. By doing continuously until you find the correct decision boundary with the greatest margin. If you look at the green decision boundary, the line appears to have a maximum margin compared to other two. This is the boundary of greatest margin. When you classify your unknown data value, you can see that it clearly belongs to the batsman class. The green line divides the data perfectly because it has the maximum margin between the support vectors. At this point, you can be confident with the classification. The new data point is indeed a batsman. Technically, this dividing line is called as hyperplane. In two-dimensional spaces, we typically refers the dividing line as lines. In three-dimensional as well as higher dimensional, they are referred as planes or hyperplanes. Technically, all are considered as a hyperplane. The hyperplane with the maximum distance from the support vectors is the one you want. Sometimes the positive hyperplane is represented as d plus. The shortest distance to the closest positive point is represented d minus, or negative hyperplane, which is the shortest distance to the closest negative point. The sum of d plus and d minus is called a distance margin. You should always try to maximize the distance margin to avoid misclassification. You can see the yellow margin is much smaller than the green margin. This problem set is two-dimensional because their classification is only between two classes. It is called as linear SVM. Some of the real-world applications of SVM are which is used in classify unstructured data, make reliable predictions, and reduce redundant information. Normally, which is used in face detection, text categorization, image classification, and bioinformatics. Some other applications of supervised machine learning are image and object recognition, predictive analysis, customer sentiment analysis, and the spam detection. Supervised learning focuses on constructing a machine learning model that can familiarize the planning between the data and the result, thereby predicting the output of the new resources.